In this video, I'm going to show you how to set up a basic model in FastGrav. I'll show you how to import geographical points and empirical gravity data. Then I'll show you how to add masses to your project and start modeling gravity anomaly curves. So first, we need to import some geographical points into FastGrav. In FastGrav, a set of geographical points is called an observation set. Each point in an observation set represents a real or imaginary gravity station that FastGrav uses altogether to calculate a gravity profile. So the easiest way to make an observation set is with Excel, but you can use a normal text editor too. So here I've just got a mostly empty new Excel document with 4 columns: X, Y, Z, and empirical. So X, Y, and Z define a point in real space or on the ground in the real world. And empirical is an empirical acceleration value. So this would be like a real value in milligauss that you recorded from a gravity station. So today we're just going to use made up data. I'm just going to sort of fabricate a data set for us to use in this demonstration. We're going to make a straight transect starting at x equals 0 meters and going to x equals 100 meters. And then we will just set all of our y coordinates to 0, just for the sake of this demonstration. And our z coordinate, so this would be represented by elevation or altitude if you were using a real data set, we'll just set those to 0 today as well. So we've got a flat, straight transect, no zigs, no zags, just x, y, z points starting with x equals 0 and incrementing all the way up to x equals 100 meters. So this is a made-up data set, so I don't have any empirical data, but for the sake of this demonstration, I will just fudge a few empirical values. We'll say that at x equals 60 meters, we will say that we've got an empirical value of 0.6 milligauss. And then at x equals 50, we'll say 0.25 milligauss. We'll also put that value in for x equals 70, so we have a symmetrical curve. At x equals 40, we'll say 0.07, and also at x equals 80, 0.07. And just so it tapers off to a nice low level, we'll put 0.001 in at x equals 90 and 0.001 in at x equals 30. So now we have some made up empirical values for certain points on our made up transect. So again, in real life, these would probably be real acceleration values that you read off of a gravity meter or something like that. But we are using fake data here, so these are not real values. We could fill in fake values for all these other points, but instead we will just fill them in with FastGrav's no data value, which is negative 999,999. So I'll just control copy that and paste it into all of these gaps. And Excel makes that pretty easy. So again, negative 999,999 is FastGrav's no data value, and it is required that you fill in points that you don't have empirical data with this no data value, because it tells FastGrav that the user does not have empirical data at that point. So now we've got a complete observation set. And in order to import this into FastGrav, we need to open up a basic text editor like Notepad. So in Excel, you select these 4 columns, Control copy, and paste them into Notepad. And you can see that Excel actually pastes really nicely into Notepad. You get 4 columns separated by tabs, by the tab character. So this is actually the format that FastGrav requires observation sets to be in. X, Y, Z, empirical columns separated by the tab character. And the first line is always reserved for an observation set title. So it's a 1-line header that consists of a title. So we'll just call this observation set Aaron's transect. And then I will save it as transect.txt. TXT indicates that it's just a normal text file, which is the format that observation sets are in. I'm going to overwrite this old file. Okay, so now I've saved my observation set as transect.txt. I can go ahead and minimize Notepad and Excel. I will start a new project here, and I will add the observation set that we just made into this project. So I'm navigating to transect.txt, and I am pressing open. So when you add an observation set for the first time, you have to specify what units your numbers are. So let's just say, since this is a made-up data set, that my X, Y, and Z unit is meters, although you could specify feet if you took your data in feet out in the field. And we'll say that our empirical acceleration values are in milligauss. Okay, so you can see that Aaron's transect has appeared in the observation set index. If we like, we can right-click on that and open a little table and look at our observation set in table form. We've got our points in this column, X, Y, Z, with X going from 1 to 100. And in this column, we've got our empirical values. We can see that we've got a lot of gaps in our empirical data, but every once in a while we have one of these made-up empirical values we added into the observation set. This column is the modeled gravity column, and it's all 0 right now because these are the values that FastGrav calculates, and we don't have any mass items in our model, so the gravity anomaly modeled is 0 everywhere right now. So let's X that out, and let's visualize, let's add a cross section so we can better look at our observation set. So a cross section window has 2 panels. There's a gravity profile panel where the acceleration unit is on the y-axis, in this case milligauss, and the distance unit is on the x-axis, meters for this project. This is where your gravity anomaly will be plotted. Down here is a sort of classic cross section. It sort of shows where mass items are, where mass objects are underground, and it is lined up with the gravity profile graph, so you can see how mass items are affecting the gravity profile graph. So let's go ahead and set our chosen observation set to Aaron's transect. And you can see that that makes all of our points appear in the cross-section panel with x increments of a meter going from x equals 0 to x equals 100. And above that on the profile graph, you can see our empirical curve, which is a little shoddy because we didn't put too many points in it, but it'll be fine for this demonstration. Our modeled curve is not shown because we still don't have any mass in our model. So let's add a mass item. The way you do that is you go up to add mass item. For right now, we'll just use a sphere. So we are editing our new sphere item. I'm just going to go ahead and call it Aaron's sphere. I'll give it a density of 2,000 kilograms per meters cubed. And I can also set the X, Y, Z coordinates of this sphere and the radius of the sphere. So just for right now, I'll set the X value to 25. I'll leave the Y value at 0, and I'll set the Z value to 10 meters underground. And we'll make the radius 8 meters. We'll color it light blue and press apply. So you can see that our sphere object named Aaron's sphere has appeared in the cross section, and we now have a modeled gravity profile alongside our empirical gravity profile. So now this mass item is actually contributing to the modeled gravity profile. FastGrav is calculating delta G at every point in our observation system and plotting it above the cross section. So once you have an item in your project, you can edit it manually by moving its position, changing its radius, or you can move it around and change its radius and some other parameters in the cross-section UI. So just for fun, we'll take a second and try to line our modeled gravity profile up with our empirical gravity profile. It looks pretty good. Okay, so I hope you have a basic idea of how to make a project in FastGrav and how to get your gravity anomalies modeled. Thanks for watching.